All right, hello everybody. I'm just wrangling slides over here while we wait for more people to trickle in. We will get started with today's interim shortly. Ahead of the official start, as usual, we need a note taker, so volunteers are appreciated.
Tim, did you get my slides?
I did, and I uploaded them, and they should be, yeah, they're loaded up. So we still don't have a lot of people in the room, so I want to wait a little longer just so that we get something more like a quorum today. Okay, it's 5 past the hour, so I think we can at least get started with some of the admin stuff and then get into today's discussions. So welcome everybody to the second or third interim that we've had since last IETF plenary. Today we'll be focused back more on protocol and architecture matters. So first off, please note well to know well. Please make yourself aware of IETF's code of conduct and intellectual property policies and the like. As usual, we need a note taker. I haven't changed this slide since last time, but in any case, since Brendan's presenting, I don't think it's appropriate for them to take notes. So we need a volunteer as usual.
I can take some notes.
Thank you, Richard. Okay, with that settled, let's, all right, so the agenda today, chair slides, which we're hashing out right now. Then Brendan's going to lead us through a discussion on privacy preserving delivery service, continuing from some discussion on the list, as well as sort of a pseudo draft posted up as a gist on GitHub. Then Rowan has some updates on Mimi content format, in particular focusing on dissecting TLS presentation syntax versus CBOR. And then with any remaining time, we're just going to go through open issues on the, I suppose there should be 3 documents there, the 3 adopted architecture protocol and content format documents. Does anybody want to suggest changes to the agenda before we move on? Okay, sounds like everybody's happy. So I'm going to switch over to, here we go. The syncing over from data tracker didn't work, but you can now upload slides, PDF slides directly into Meet Echo, which is a really nice way to last minute get a deck in. Okay, so Brendan, I'm happy to drive the slides for you. Otherwise, take it away.
Is it possible for you to pass to me? Or do you want to drive? Okay.
Which button is it? There we go. That. And then I click that.
Cool. Yeah, so like Tim said, this is a document that I shared towards the last of towards the end of the last IETF, because there was an adoption call for a Mimi protocol and a Mimi architecture. And I had some feedback. In particular, I was concerned about the privacy aspects of the protocol document as it was shared. But if you kind of start from the top of what does a Mimi delivery service actually need to do, there's a couple of things. The most important, I would say, is probably access control. So when you create a group, you want to be able to control who is able to send and read the messages in that group. I mean, they are all encrypted, but it's still better if you can make sure that people that aren't in the group can't read messages or send a bunch of junk messages and make it really hard to participate in the group. And sort of as a step down from that, spam and abuse filtering. So to the extent that spam messages get through access control, you still want to be able to detect and remove those. So whenever someone is just sending like a bunch of junk messages, you want the delivery service to be able to remove those so that users don't have to receive them and process them, and also so the provider doesn't have to store them for a long time and like waste disk space. And there's a lot of other things that the delivery service needs to do, but just sort of starting with those as like the top line. The current approach in the Mimi protocol document is that it does this with commit inspection. So whenever a commit is sent to a group, the delivery service is supposed to look through all of the proposals in the commit and see how that affects group membership. And so it does that to always keep tabs on which users are actually supposed to be in the group. And also I think sometimes it will send proposals and it will enforce that the next commit to the group has to include that proposal so that it can enforce changes to the group state as well. The reason that's not great is first of all, you can have invalid commits. So the provider is not actually in a position to verify that commits are valid. But what it's doing in the current Mimi protocol is that it's trying to enforce that certain commits get accepted. So you have the kind of obvious issue that I, as a malicious client, can send an invalid commit the provider will see that. It will look valid to the provider because the provider can't actually verify it. And then it will try to force everyone else to accept my commit, and everyone else is going to get blocked on trying to process this commit, which is not actually processable. You also have issues with no membership privacy, like I said. So it requires, if the DS is going to inspect every commit message, it requires that all of the handshake messages be public. And so the DS always knows everyone who is in the group, even if those users are not members of the provider's own service. So I can see, if I'm like a little service provider federating with like Facebook, I can get personal information from all of the Facebook users that ever interact with my service, and that seems wrong. And so we talked briefly about pseudonyms, I think, in the last IETF, not IETF, the last interim. And I mean, that's kind of a solution. It does have a lot of implementation baggage in terms of who can be added to a group and who can add someone to a group, because you need to have a connection with the user to be able to add them to a group. And it actually has the same issue with invalid commits as well, because it doesn't address that issue. Yaron?
Yeah. So in terms of the, you mentioned this issue of being able to see what is all the user. You're a small provider, being able to see all the users on the Facebook side. But with pseudonyms, this is definitely more of a hiding in plain sight in that direction, but it's actually more of a concern in the other direction, where there are a relatively small number of users on a less well-known provider. Then the likelihood that it's a handful of specific individuals becomes much higher.
Yeah, that's a good point. I actually didn't think about that until you sent your message to the list, that your provider is kind of an anonymity set. I mean, especially with pseudonyms.
Yeah.
Richard?
Yeah. I just wanted to clarify a little bit whether to what degree the concern here is about the hub provider versus other providers that might be participating in the room.
The concern for membership privacy or for invalid commits?
I guess either way. More so than membership privacy, I guess, because it seems like clearly for the access control point, the hub needs to know the membership of the room, unless you have some magic solution for that. But maybe we could deny that information to other people.
I mean, in the current protocol document, I don't believe that you have membership privacy from any of the participating service providers, because all the commit messages are public and everyone can see the commit messages. So every provider can see all of the members of the group.
Yeah, that's correct. I was just trying to get an idea of what you were trying to solve for with this.
So what I would like, the property that I'm going to talk about sort of towards the end of the presentation, is that I would like Rowan said, your service provider to kind of be an anonymity set, where if I'm a hub provider and I add a user from Facebook, I would ideally not see which user of Facebook my own users are talking to. I would just see that we're talking to someone from Facebook. So the point would be to make sure that the social graphs of different providers are not shared between different providers. The social graph that you have stays local to your service provider, and then you can branch out to different service providers and like rely on their social network, but you can't learn about their social network.
Okay, thanks. I'll look forward to the rest.
So the question that I got when we were talking about this in terms of the adoption call was, how would I actually solve this problem? So that is the next slide. So if you think about like what an idealized MLS group looks like, it tends to be drawn sort of in a single line, where you have a single epoch, and sort of the dashes in this line here denote application messages, and then the circles at the end of each line denote a commit. So you send a bunch of application messages, someone sends a commit, and then that immediately starts a new epoch. and you kind of keep going like that. So each epoch has a single commit, which starts immediately a new epoch of application messages until someone's in the commit, and you've got one commit per epoch, and it's always very nice and clean. And if you're sort of naively implementing a delivery service, this is probably how you would be inclined to try to implement it at first. But kind of like I talked about on the first slide, in reality, forks are inevitable because multiple commits can always be sent. They can be sent by accident because there's like a race condition, or there was a bug in a client where it accidentally sent a commit which was not valid. But it could also be sent maliciously by somebody. So this is actually a point where Mimi specifically really does need to be robust to this, because if you're building MLS in like a closed source code base, you can have a lot of confidence in exactly what code is interacting with your server. But if you have an open source code base, or in Mimi, a federated code base or a federated environment, the minimum quality of code that's interacting with your Mimi server is going to be very low. And so you're going to have a bunch of junk, and you have to be very robust to people sending junk to your server. And so when there are forks and there are multiple commits, and you as the delivery service are not in a position to decide which one is right, you have to be able to handle forks. So the way that we do that, one second. So the way that we do that is essentially that we put each epoch in its own little box. And inside of this box, all of the messages are ordered linearly. So you have a complete linear order of messages that are sent within the epoch. But then each epoch sort of gets put in its own little box, and they're all separate. And there is not a strong connection between the boxes. So kind of like I drew here, we have multiple commits in one of the epochs in this box in the middle. And then we have multiple subsequent epochs that come after that. There's kind of an implicit connection that, you know, one commit was added to this box, and then it created this next box. And so it's kind of like a directed acyclic graph instead of just a line like we have in the ideal MLS case. And so to actually make this usable, what we do is we give the boxes each IDs, and the ID is what clients, so either actual users or remote service providers, will use when they interact with the Mimi service. They'll refer to boxes, and they use that ID to identify which box they either want to send their message to, or which box they want to read messages from. So if you're starting here in box A, then you can say, I want to read all the messages in box A. And then once you get to the end and like you want to send a message, you can tell the service provider, I want to send a message to box A, and then it gets added to box A. And it's sort of separated from all of the other boxes. It's contained to this one little area. And so if you think about how does reading messages like across several epochs actually work with this sort of system, if I'm a client and I'm starting in box A, then I'll read all of the application messages in box A. Then I'll get to this commit, and I will accept it because it's a valid commit, which is why I circled it in green. And then once I process that commit, I know that the next box ID is box B. So then I go to box B, I download that from the service provider, and I read all of the application messages in there. There are some commits which are X'd out because my client doesn't like them for whatever reason. Maybe they're malformed, or there's some sort of change happening in the commit that I don't think should be allowed, like adding someone to the group that shouldn't be allowed to be added to the group. And so basically I just skip over those invalid commits the same way that I would skip over any invalid application message that was maybe signed wrong. And then I get to this last commit, which is in green, so I like it. So I process that commit, and then I move on to the next epoch. So it's this kind of jumping from box to box, where after you process a commit, you learn the next box ID, and then you jump to that box, and then you read all the messages in there, and then you jump to the next one. And so in that way, you're kind of following a single path through the graph of boxes. Yes, Rowan?
Yeah, I don't know if you were planning to go into this in the next slide, but the problem with if the client reading this in box B decides that this commit that it received is invalid, and somebody else in the group thinks it is valid, dealing with that, particularly if it's a malicious client or a bug, that's a sort of a classic hard problem, without a quorum and without some kind of central resource to be an arbiter.
Well, so the central resource that's an arbiter in this case is the code base. So everybody needs to have the same policy for which commits are acceptable and which aren't. And that's actually true for vanilla MLS as well. Is anytime you run MLS, everyone needs a policy to determine which commits are acceptable and which aren't. And everybody needs to agree on that policy, or else you have the problem you just said, which is that people will fork, and that's a bug.
Well, I mean, it's either a bug or it's a malicious client.
Well, no. So if you have a malicious client, that one malicious client will send their invalid commit, and then they can go off on their own box. But the service provider will see that everyone else ignores it and goes somewhere else. So that malicious client will kind of fail in causing any disruption to the group, because everybody else jumps over their commit and goes to the next valid one. Whereas if you had a delivery service which tried to say this is the correct fork without having any kind of quorum, then there's the potential that the delivery service could decide that one of the malicious invalid forks is the one that's going to force everyone to accept, and then that breaks everyone. So the fact that we allow forking allows the quorum mechanism that you were talking about to happen in the background, sort of as like a garbage control, where we can see, oh, this fork was created and nobody ever used it. That's probably trash. I can delete it. But it's not something that happens proactively, where I say, I'm going to actually block messages being sent on everybody telling me which fork is correct.
Okay, so in your opinion, does the reaction of the hub, or of one of the providers, depend on there being more correct implementations than buggy implementations, or more honest implementations than malicious implementations?
I mean, it's really hard because, I mean, like I said, the delivery service is not in a position to decide which commit is valid or not. So yeah, it kind of does rely on there being more honest, not buggy implementations than there being malicious implementations. It's like a civil problem, I guess, is what it would be. Eric?
Yeah, I guess I'm still trying to follow exactly what happens here. So as I understand it, what you're saying is if there is an invalid commit, which is accepted by some set of people, but not by others, then effectively you get a partition, and you have some set of people are in box D and some set of people are in box C, for instance.
Yeah, exactly. You get a partition where everyone sort of branches off in different directions and they continue on their own.
Okay, and you do not have a specified mechanism for cleaning that partition up.
I mean, the specified mechanism is that the service provider sees, you're echoing my own voice, which is making it hard to talk. Thank you. The specified mechanism is that if there is a fork where half of the group goes up in one direction, half the group goes off in the other direction, there really isn't a proactive thing that you can do in that case to say who is right. So what this would allow you to do is allow those two forks to kind of continue on their own happily. And the service provider can look into that later and see, oh, there was this weird group that forked. Like, can I find anything common between the clients that went off in this fork and the clients that went off in this fork? Like maybe all of the clients that took box D instead of box C, like my own clients all took box C. So I know that box C is the correct box because my client is perfect. And then like everyone from Facebook took box D. That's a bug that I could report to Facebook and say, hey, you're not validating commits properly. So that's the mechanism, is that somebody notices and figures out what's in common between the clients who took one fork versus the other, and try to resolve it in a human way.
I would call that fairly underspecified. That's
Yeah,
not
but there's-
operationalizable.
yeah.
Okay, well, so I guess I'd like, if before we move further down this chain, I'd like to be persuaded it's not possible for a attacker to induce a situation where some set of people that are victims are part of one partition, other people are part of another partition. Because the current design does not allow that, and what you're suggesting is allowing that. So it's fine. So it's fine if the attacker can. So it's fine if the attacker can only partition themselves into some partition. But if the attacker can say that you and I are in one partition, and that the attacker and Rowan are a different partition, that is very bad.
I agree that is very bad. The only mechanism in MLS that actually would allow that to be possible is if when you send a commit, you do the thing where like half of the update path is invalid and then half of it is, or basically the update path as it goes up the ratchet tree, one half is different than the other half. So people that are in a certain subtree wouldn't be able to verify the commit and they would reject it. And then everyone who is outside of that subtree would accept it. And so that's the only mechanism where you could sort of separate people out in a malicious way. But I think that you need a different mechanism essentially to deal with commit messages that are invalid like that.
Hey, I was mostly commenting on Ecker's comment, just saying that, with the current mechanism, there are already things where the clients can say, I can come. It's challenging, but the clients can come up with commits where they could fool the provider, or they could fool the hub. But the thing is that there is recourse if somebody detects that, wait a minute, like the hub just said that this commit, which I think is invalid, is wrong, which is through the external commit mechanism, that it can basically rejoin the group and kick out somebody that it thinks is misbehaving. But there's exactly one point of control for that. So the number of sort of code paths that you have to follow, you have one remedy. It's kind of like going to a judge and saying, hey, the two of us disagree, right? So I think what Brendan is proposing, there's a kernel of something potentially valuable, interesting, useful there. But I am also concerned with the general problem of having sort of an explosion of different combinations of things that could happen, and like not a single recourse to get everybody back on the same track, that particularly in the case of a bug.
Right, that's a good point. I mean, the branching is concerning, but in terms of actually like operationalizing this, or like, I guess the question is, what do you do when there is a bug? And the current MIME specification says that half of the group gets stuck and broken, and the other half can continue. Versus more so what this is, which is the two can kind of keep operating. They would just get separated from each other, and then someone in the background could go and figure out what the bug was. But yeah, I think we've talked about this. So we understand how reading messages works. So basically you jump from box to box to box as you kind of read the messages in each one. So to dig a little bit deeper on how access control works, I said last time that the ID of each box is used to read and write messages to that specific box. And you sort of combine that with the second point, which is that the box ID is going to be a sort of big random secret, which is derived from the MLS key schedule. And so only people who are actually members of the group in that specific epoch are going to be able to derive the box ID. So they're going to be the only ones that know this big random secret to be able to send requests to the server to ask about that specific group. And so that's the general principle about how only group members are allowed to participate in a specific epoch. And this is also nice because it acts as kind of an access control mechanism and also a spam control mechanism, where if you're a spammer and you just want to send a bunch of random messages, once you get removed from the group, you don't actually know the next box ID to send messages to. So you can maybe keep sending messages somewhere, but the point is that nobody is going to read them because they're all reading messages from a different box already. And so actually, we've kind of already digested this a lot in a couple slides ago with the reading messages. But the way this helps with invalid commits is that if there are invalid commits that a client sends that it shouldn't have sent, that creates forks. Those forks are allowed to exist, but honest, correctly implemented clients will never actually pursue those forks, so they don't have to process those messages. They don't have to get stuck on the delivery service trying to force them to accept a commit, which is invalid. So they can kind of keep continuing on, and then the buggy clients go off in their own fork, and the buggy clients will, eventually figure out that something was wrong and kind of deal with that themselves. To Ecker's point, that this is not really operationalizable. I would argue that there's not really a way to make it operationalizable. Like if someone has a bug in their client, the best that you can do is kind of allow that bug to happen gracefully and let the client fail out on its own without blocking and getting everyone else stuck. But that's what helps with invalid commits, is that you can allow forks. And then in terms of spam deletion, whenever you have either a malicious client or a buggy client, which is creating forks and sending commits, they're going to create new boxes, and those boxes are going to have messages. And that is something that the service provider is going to have to store, and also something that the service provider is not going to know to delete, because it's not going to see everyone read the messages. It's just going to be holding on to it, waiting to see if people read these messages or not. But I guess in time, sort of in the background, you can say, oh, well, this was a fork of this group. Nobody ever pursued that fork except like this one buggy client, so I can just delete that fork. That's how it works, is basically just tree trimming, essentially, when you have forks of a group which are which have no one interested in reading them. And then to get back to Rich's questions about how does this help with membership privacy? So this picture is a diagram of essentially what a hub provider would see when it's running a group. So on the left side, we have all of the hub's own users interacting with the group. And so the hub can see which of its own users are interested in the group, and it can see which messages they're wanting to read and all of that. But when group membership or when handshake messages are encrypted in MLS, the consequence is that the hub provider has no visibility into the service provider's users. So on the right side of the graph, all the hub sees is that, remote service provider 1 and 2 seem to keep knowing the next box ID to get messages from. So that implies that they have users which are in this group. Richard.
Feel free to tell me this is coming, but I'm wondering how, like, I see kind of what you're thinking with the boxes once the group is running, but when you're talking about pre-group stuff like fetching key packages and getting consent, that's a little less clear how you hide things in that.
So in this presentation, I actually didn't include any of the key package stuff in terms of how a user would fetch a key package privately. But essentially the core idea that I had was if I'm user A at my hub provider, and I know that user 1 is at remote service provider 1, then what I would do is I would send an oblivious HTTP request through my hub provider to RSP1 to get user one's key package. And the purpose of using oblivious HTTP is that the hub provider would not be able to see what I requested from RSP1, and RSP1 would not be able to find out who from the hub provider is requesting the specific key package, except if they have like a bearer token, which is used to authenticate within some kind of anonymity set.
Okay, thanks.
But yeah, this is the core idea. If you think about what the hub sees, it sees which of its own users are interested in a group, and it sees which remote service providers are interested in a group. And also what this means is that certain tasks are kind of delegated to the service provider, which is local to a given user. So there was an example on the mailing list recently, which is like if a user gets compromised, I want to be able to remove them from all of the groups that they're in so that compromised key stops being used. So if I'm the hub provider, I know which of my own users are in a group. And so I can send a message to that group saying, hey, please remove user A because their key is compromised. But I would not necessarily be able to see anything about user one or user two from the remote service providers. So when the remote service provider finds out that someone is compromised, they have to send that message on behalf of their user to the hub. There's no way for the hub to know sort of which of the remote service providers users are in the group or not, which is intentional, but it's just a consequence, which is that only the service provider, which is local to a user, knows which of their own users are in a group. And it's also worth pointing out that this is not required to use handshake message encryption. It's just an option. Like you can still use unencrypted handshake messages if that's something which you need for other reasons, but it's not required for the core delivery service functionality, which is what I was trying to achieve. Alyssa.
Can you talk a little bit about whether or how you could sustain?
Alyssa, your audio is super faint.
Okay, I'll put it in the chat. I don't know why that is.
So I'll wait for Melissa to write her question. But to go to the next point, there was some concern in this proposal because you are kind of following a directed graph that there's a lot of hops that you have to read all of box A before you can go to box B, and then read all of box B before you can go to box C. And if you have little epochs or frequent epochs, that can be a lot of round trips, and it can make it really inefficient to synchronize with the group. So if a service provider is reasonably confident that a series of epochs will all be requested together, because every other client has requested all of these epochs in the same order, and so we have kind of that quorum that, we have the quorum that the proper series of epochs in the group is box A, then box B, then box C. What you can do is you can provide them all together. You can provide all of the boxes together, which you could call a palette, if you will, a series of boxes. Basically what happened is that someone would come to the service provider. They would say, I would like to read the messages in box A, and the service provider provides back box A, but it also provides back boxes B and C because it's pretty sure those are next, with just the one caveat that you hash the box ID to prevent leaking the box ID if the user was removed in one of these epochs and we weren't able to see that. So I was wondering how this interacts with inter-provider user blocking or any other user reputation-based actions providers might need or want to take. That is an issue where I can't see who is in this group as the hub provider. So my visibility into the group is not, user one from RSP1 is being malicious. I can only see I'm getting malicious traffic from RSP1. This person is creating a bunch of forks. They're sending a bunch of dumb messages nobody reads. They're trying to waste my storage. I don't like that. So this is actually, yes, this is the point that I was talking about before, where certain things get delegated down to a user's local service provider. So if there is malicious action, there's spam or something, the way I envision that working is that the hub provider initially reports that to the remote service provider, and it says, hey, someone in this group is being malicious. I can't see who it is, but you can. So you need to figure it out and stop it. So there would be this initial mechanism of basically sending reports to the remote service provider saying that a certain user, I don't know which one, is being malicious. Can you please fix this? And if there is sort of a pattern of, every time I had someone from RSP1 to a group, then I have a bunch of like malicious wasteful traffic. So I'm just going to stop federating with RSP1. I'm going to stop talking to RSP1 altogether because all of the traffic from them seems to be malicious and they don't have control over the abuse of their users. So that's how I would picture that working. But yeah, that's all I have. That's on my slides. Are there any more questions?
I had some implications I wanted to bring up, and I'm quite pleased that you wrote this up, right? This is good. This is fertile ground for this kind of discussion. So even if I disagree on what we should do at the moment, I think that this may cause us to have a kind of a breakthrough on some of the privacy requirements. But the three implications that I was typing up in the Zulip here. So of course you mentioned the frequent epics where the client needs to stop decrypting, send a request, wait for a network response, get more information, decrypt. You've partially addressed that, but I don't know that you can. The hub can predict easily whether it's hash B prime, hash B double prime. There could be like quite a proliferation of those. The second thing is that the hub can't remove deleted users, not even with an external proposal, because they don't know the leaf index of their users if they're not privy to the commits. And so then they don't know what the structure of the leaf, which leaf nodes correspond to which even pseudonyms. And then the last thing is is external commits. Like under all of the systems that the people in the design team were associated with, the hub has the group info and a client that wants to join, it can ask the hub for help to do an external join. If that wasn't the case, the joiner could still send an external proposal, or it could go fetch a group info from an existing member and do an external commit. It's just that in a small group, this means that a user that wants to join or rejoin, that they can't take any action until another member helps them out.
Okay, those are good points. To go through them. So the first one you were talking about is that when there are a sort of large proliferation of forks, that this approach of trying to proactively provide the next epoch doesn't really work because you don't know which sort of fork is actually the next one in the epoch. And that's true, but also I would say that producing a lot of forks is more so a sign of abuse. So, if there are a bunch of forks, then you would not be able to proactively provide the next box because you don't know which one is next. But the user would be able to request which box they want next. And that would sort of allow you to traverse the the tree a little bit more efficiently.
So you're saying that if there's only one if only one commit is received for a particular epoch, then then you consider that to be business as usual, and the server just sends stuff. But like if I have two commits that both arrive approximately the same time, or if I have a large group and I have a handful, like 5 of them that all kind of were sent and like several were in flight as another was arrived at the hub, those don't represent an error state. That's just sort of a normal busy network.
Yeah, I would say that's a normal busy network.
Okay.
And also, I would just say that the way that you think about these sort of extra boxes that are provided is a semantic more similar to like an HTTP to push kind of thing, where I am providing this data proactively, but it's totally valid for you to never request it. So if I provide the wrong box, then you just kind of ignore this and you send another request for what you actually do want. And so you've got the usual trade-off, which you have with things like HTTP to push, which is you have to balance wasting the client's memory by sending a bunch of things that they're never actually going to want, with the potential of saving this round trip. That's kind of the dynamic. I think that essentially always you would have just 1 or 2 commits in an epoch, and you would have a really good sense of which box comes next. I think that essentially always you would have a good sense of which box comes next, but there is sometimes that you, there are sometimes that you would not, and in that case you would not provide the push, and you would just let the user request which comes next instead of try to waste their memory sending a bunch of junk. Yeah, and then for the hub removing deleted users, I think that you would actually probably need a new proposal type, which says remove user with this credential hash or with this identity or something that is signed by the user's own local service provider. Because like you said, you don't know the leaf index, so you can't send just a normal external remove. But yeah. Anything else?
I mentioned the external commits, but I mean, you don't necessarily need to comment on all of these, right? It just is kind of more of like, we need to figure out what the requirements are.
I think that you can still do external commits with this. You just have the issue that when there is a fork, so when the most recent epoch is a fork, the server doesn't necessarily know which epoch to let you externally join. But I mean, in that case, it is actually unclear what to do when there's a fork and there's multiple potential epochs for you to join. You kind of have dealer's choice. You could say the server lets me externally join the one epoch that it feels the most confident about, or maybe it lets me externally join multiple epochs and like see how things go. I don't really know. But external join is something that you can do with this. It's not required. Yes. Are we out of time, Tim?
No, we're not really out of time. I mean, we do need to eventually get to run stuff on content, but I think we have time to keep talking about this. What I want to discuss is, like, what do we do next with this set of ideas? In particular, because, like, I don't think we have a clear consensus right now, and in any case, there aren't enough people here in the interim today to, like, formally make decisions, as it were. So it sounds. Richard, did you want to interject? Or do you want to go?
No, go ahead. I was going to go after you.
Okay, so I think there's 2 things here, right? One is, as Rowan was arguing, there's like some new implied requirements that the working group probably needs to consider and either accept or reject. And then past that, there's like solutions to those requirements, which Brendan has been explaining to us. So what, as a working group, do we want to do with these things? Like, at a minimum, we got to take all these ideas to like a wider audience for consideration. But so with the requirements, would those manifest, say, as changes to the architecture document or the protocol document? I guess we can open the queue to thoughts on that, like how to proceed with digesting these requirements.
Yeah, I mean, ultimately, these things, like if we end up moving more in this direction, we would make changes to the architecture and the protocol document. But I think we've got some rounds of discussion to do before we get there. I think you're spot on that, we've got some, we're getting some clearer thinking on some requirements that had been a little latent before, and getting those out. And as we were just discussing, some limitations that come along with this. So like fleshing out the trade-offs that are involved with this proposal. So yeah, I think what seems to me like the next step is for Brendan, maybe with some help from Rowan, to kind of put together a concise description of the trade-offs, and as a guide to kind of the working group in figuring out which way we want to go with this. I guess it would be good, like taking the proposal as it is and understanding its trade-offs better, but it may be that there's some, that could be a guide to also how we might adapt this, if we were going to say, take some parts of it and use those and leave other parts aside. Rowan?
Yeah, I was going to say, I think that the privacy, like getting privacy threat models outlined and some of these additional requirements documented, I think that's a good way to get us moving toward, like it maybe we come up with, okay, like, well, this isn't really great over here and this isn't great over there, but we think that this one is better based on the requirements that we need to satisfy. And it may also be that in some cases that we may end up with, one hub chooses a particular trade-off over a different hub provider, and that we have more than one way of doing things, but the clients have exactly one way to do things and know what they need to do at all times. I think that would also be an acceptable solution.
Just pausing to let anybody else jump into the queue who wants to. Okay, so it sounds like the path forward here is for Brendan and or Rowan to continue to flesh out these ideas on the list with an eye towards converging towards a proposal for like either, excuse me, a new draft discussing these things, or figuring out like how to incorporate it into existing drafts, manifesting that perhaps as a set of pull requests, which we can then discuss in the working group and at future interims. Richard, anything to add?
Yeah, I think maybe an issue on the architecture repo would be a good place to kind of memorialize this, or on the mailing list. Do we have a couple seconds more for some discussion on the proposal, Tim?
Yes, absolutely.
Okay, yeah. So Brendan, I just had like a really prosaic question. I kind of get how in a pure poll model where the clients are asking for like, give me this box, how this works. Is there any notion of fan out here, like proactively pushing stuff down to interested clients? And I guess if we're aiming for that, not clear to me how that works. Although I guess pushing to clients isn't really what this working group is about. But I guess server to server, service provider to service provider is even still interesting, because like, how does the hub say keep track of which service providers are involved in a given box, so that the hub knows which service providers need to know when there's new messages within a given box?
So in terms of which service providers and which users are interested in a given box, I think that you would have a kind of Mimi level concept of subscribing to a given box, where if you know the box ID, then you can, I guess, subscribe to push requests about new messages to that given box. So that's how you would do push, is you would say, I know this box ID, please proactively send me new messages to this box as they get sent and as they get sequenced by the hub. And then once you send a commit and there are subsequent epochs, you would instead have to switch to the HTTP2 push kind of idea that I have on the current slide, which is where I am providing you proactively what I think the next epoch is going to be, just with like the box ID hashed in case you are not actually in this group. Then I am not leaking the box ID, so you can't send messages to epochs that you're not in the group. Does that make sense?
So it sounds like at one level, you're just kind of indirecting the pull model by the subscribe model through the service provider. Is that
Yeah,
kind of the
that's
idea that a client connected to a service provider would say, hey, I'm interested in this box, and the service provider would say, dear hub, please tell me about this box. So there's a little
Exactly,
bit
yeah.
of round tripping there. Okay. Yeah, it would be good to kind of get some of these.
I think you might have muted prematurely, Richard. Your thought got cut off.
Oh, sorry about that, Dave. Just thinking as we flesh this out, like understanding some of this kind of basic physics would be a good thing.
Brendan, in your mind, if we've got the sort of the normal case where we've got 3 clients that all send a commit, you know, from their perspective, a valid commit, and if the other 2 commits didn't exist, everybody else and all the other members would agree that it was a valid commit. And so the only thing that would be making one of, the 2 of these to be invalid commits is that they arrive later. How do you see communicating that using your model?
I don't understand how that could happen, that you would have a commit which is invalidated by a commit that comes later. Like the normal mechanic in MLS is you say the first valid commit is the canonical one.
Right. So nobody knows what the first one is because the first one is, the first one that arrives at the hub, right? You don't know that when you send it. You don't know that if somebody else already has one in flight to the hub. And even if I have 2 that are in flight at the same time, I don't necessarily know which one of them is going to arrive first.
Mm-hmm. I mean, that's the core kind of service that the hub delivery service is providing, is that it's sequencing all of the messages that get sent in a linear order, at least within a specific box. So if I send a commit, I generally would not know that it's the commit that gets accepted. I would send it, and then I would continue reading from the box and see which commit came first. And if it's mine, that's lucky, but if it might not be.
Okay, so in other words, the order of a commit that arrived in the box tells you that it arrived. That tells you, oh, I need to go in this particular direction. I need to roll back the commit that I made and start the new one. Okay, yeah. That sounds reasonable.
I think that's normal for MLS, is that whenever you produce a commit, it's kind of provisional, and then you send it to the server and see what happens.
Yeah, I agree with that. It was just more like what's the feedback mechanism, and the feedback mechanism is that the commit arrives, that you read the commit from the box.
Mm-hmm.
Okay, we're at the end of the first hour, which is fine because we've just been eating into time that was reserved for scrubbing bugs and PRs on the repositories. So it's perfectly okay for us to have been, using that time instead for this, which is more valuable. But I would like to move on to Rowan's updates on content format stuff, just to make sure we have time to get through that. And we can return to this topic should we have time after discussing content format business. Yeah, so okay, Rowan, are you ready? We can move on to your deck.
Sure.
Where's your deck? I can drive it for you, or you can request slide thing.
Yeah, go ahead. Okay, so we had a bunch of we had a handful of things that we wanted to talk about, but the biggest issue from the last ITF was whether we use CBOR or TLS presentation language as the concrete syntax. So we had a roughly 50-50 split of the group last time when we were in Brisbane. And then it was like, okay, I proposed to go off and write a new version of the draft that has both concrete syntaxes. So right now, if you go and look at the 03 version of the draft, you'll see that there is all the structs in the beginning are in TLS presentation language. The examples are in TLS presentation language, and then there's an appendix that has the CDDL data language format and all of the examples in CBOR. And then there's also in the GitHub directory, there's a whole directory full of example messages that were actually, are in CBOR and that validate to the CDDL that's in the draft. So I'm just really curious, first of all, has anybody read the new version of the document? Skimmed it, yes. Okay, so I'll sort of give a little bit of I will provide my framing on this, but I think the best way for people to get an idea of this is to look at some of the messages side by side, or to like look at what's in the document. At least skim it. It's not, it hasn't changed that much, and the differences between the TLS and the CBOR, it's not a tremendous amount of work to go and look at this. It's not a huge. I don't think that it's a huge investment of time for somebody who's already read the document. So we've got. I'm just going to kind of like go over some general points here from this slide. So in the TLS presentation language, this was originally developed for use in TLS. Wasn't really intended as a generic tool, but it has since been used for MLS. It is not a formal schema or data model language. It just specifies the structs. And so consequently, the extensibility is accomplished largely using like a type or an enum, which is then there is like a select statement, which says if this thing which I'm selecting on has this particular value, then the following contents underneath are incorporated. And so it's not like it's not like we have sort of a formal language with which to define things. This stuff is done largely manually. Likewise, there's not a lot of sort of standard tooling for decoding, debugging. That said, the format itself is fairly simple if you want to roll your own, debugging library that pretty prints or annotates a TLS message. But there's not like a standard debugging format that I know of. All right. Now, the convenience here is that this is already used for MLS, and currently, notionally, we're using TLS presentation language for the MIMI protocol because we wanted to incorporate or borrow certain structs that we use in MLS. A couple of other little points on TLS. So right now, if you have vectors, vectors have a variable length. So if I've got a vector that's 63 octets or less, I can represent that using a single octet. If I've got less than let's see, what is it? It's I think 4095. Then or 16,000, 16K minus 1, then that's represented using 2 octets, and a larger value is represented with 4 octets. So this requires bit shifting because the upper 2 bits were used as effectively to decide on the length of the length. And this is not super straightforward in JavaScript, for example, but Tim said in Brisbane, he said that they did an implementation and that this works. So it's possible, but it's not necessarily like the most natural thing for folks. And then let's see. Also, one other little detail is that the lengths of vectors are always given in number of octets instead of the number of units of the thing that is inside the vector. Okay. On the CBOR side, so CBOR is a general purpose format for carrying binary data, and its historical motivation was for a binary format that was compact and could work well on IoT devices, for example. But since then, it has a few other uses, and it's being used in Jose, which is the like assigning format similar to Jose that you could use to carry, for example, the moral equivalent of JSON Web Tokens called CWTs. There is a formal data definition language called CDDL, which was designed to be able to be used for both CBOR and JSON. And it has functionality comparable to what you would get largely comparable to what you would get in JSON schema for the, at the sort of 90% level. In terms of tooling, the initial tooling was largely written by Karsten and Ruby, but there are tools available in handfuls of tools around to verify the syntax of a CDDL schema, to verify the basic structure of a CBOR document that you don't have a schema for, and finally to validate an instance of a CBOR document using a CDDL schema. CBOR can be converted into a variety of formats to make it easier to read. So it can be converted into JSON. That's a lossy conversion. It can be converted round-tripped into a sort of diagnostic notation and extended diagnostic notation. And then finally, there's also a pretty printed hex format, which has been adopted by tools. And so if you go to the CBOR playground, cbor.me, if you type in a document, you will see the corresponding hex values in this pretty printed format. I would say that the pretty printed hex format is about as easy to read as the annotated TLS presentation language formats that I did for these examples. And the extended diagnostic notation is actually way easier to read. And let's see, finally, there is a deterministic, so CBOR has a couple of different variations or a couple of different ways that you could convey the same information, but if you use deterministic CBOR or come up with another profile like deterministic CBOR, you can trivially ensure that there's exactly one representation of every instance document, a canonical way of representing it. And let's see, there's no bit shifting, but small length items are stuffed together with a type code. So there is some bit masking that's necessary, or a jump table to implement CBOR. And then all of the lengths, like instead of having vector lengths in octets, item lengths are in units. Okay, next slide, please. Actually, were there any questions about that overview slide or comments about that overview slide? Okay, moving along. Okay, so I took the TLS structs and a CDL schema for the content format, and I split it up into two halves. Basically, the half that covers the non-body part of the message, and then the part that covers the bodies. So if you look on the left-hand side here, the format of a message is there's an optional replace this message, there's a topic ID, a value for expires, an optional reply to info, a list, a vector of last seen messages, a vector of extensions, and then the body. And then in reply to consists of 3 values down a little bit lower. And then the extensions are basically just defined as, I would call this as a poor man's hash map here. Now, if you look over on the other side, we've got same kind of content here, but this is slightly more expressive in terms of the typing. So there are some built-in types. So a B string is a binary string, or bytes object. We have the concept of a null, and so you can have a null or something. But this can be written pretty. This can be written pretty quickly, and it's relatively compact. It has no great, nothing great here motivating one thing, one choice over the other, but the sort of the language expressiveness is a little bit greater in CDDL. All right, next slide, please.
So before we move on, I just wanted to interject. You said the phrase a second ago, like a poor man's hash map, which made me think. So we've been using TLS presentation language over in the distributed aggregation protocol, and mostly it's been fine, but it is occasionally frustrating. It is occasionally a point of friction that you don't have like a nice handy hash map type thing there, but you end up having to come up with these sort of bespoke constructions each time, which is a bit of a hassle. I wanted to just get that like implementation experience note on the record.
Yeah. Okay. So this section here describes a little bit this slide shows for the body formats the comparable structs and schema. So without going into super gory detail, I want to point out 2 aspects here. So the extensibility model is that we have, if you go down toward the bottom of the left column here, the last struct called nestable part, it has disposition language, part index, and cardinality, and then it has, depending on the cardinality, it has different components that are included in the struct. So this is not necessarily the most like natural way to go and express this. By comparison, if we look up at the upper right hand, the right hand column on the first production there, nested part equals a map of disposition, language, part index, and then one of null part, multi-part, external part, or multi-part. So it's a little bit clearer to a reader what's going on, but in terms of what actually is allowed, what actually validates in the schema, it ends up being something that that is identical, you know, functionally identical to what is on the left-hand side here. Now, the last thing that I wanted to point out here was for the extensibility of things like enums. So in the bottom right-hand corner, I have this thing that says base dispos equals, and then there's a list of enums. And this matches the list of enums a little bit over to the left for disposition. And then I have something that says unknown dispos is basically this value from 9 to 255. Then if you go all the way up to the top right, under nested part, it says disposition is base dispose or $X extended or extension dispositions / unknown dispositions. And so there's a sort of a priority here that's that if you come up with a future extension disposition, it takes precedence over an unknown disposition. So if I come up with a value 10 later on, and I have defined that 10 is the foobar or smell-o-vision disposition, then that disposition will be noted in the schema and when validating and when doing diagnostics over the generic. This is a valid range for a disposition, but I don't know what it means, but it's an unknown one. So that's kind of a nice little feature. But either way, we can do, we can express everything that we want in both of these syntaxes. All right.
Hey, Rowan.
Next. Yeah, go ahead.
Hey, so I wanted to mention there's a bit of a sharp edge here with the TLS stuff that I think this illustrates nicely. This will not production on the left will not correctly parse unknown, is not extensible for unknown cardinality values because you don't know how to parse that, the length of them. So typically the way you deal with that is you put a length field right before the select that tells you how long the thing after it is. Because otherwise what happens is if you receive a value you don't recognize, then you don't know how to skip over it. And so like it's totally fixable, but it's just a sharp edge here, which I think CWARE actually handles better.
I agree with you. I think in the case of the cardinality has an ending value of 255 as well.
No, I think what Ecker was saying was that if you wanted to have stuff, you'd be able to tell where the end of that nestable part thing is and handle unknown cardinality values. You need to know how big the stuff in the struct is. So like if you look at the extension struct in MLS or the TLS client hello, right? Like each extension has a type, which tells you what it is, and then a length that tells you how long the data are. Yeah,
indeed. Yeah, in this case, the cardinal, like it wasn't intended for cardinality to be something you would ever pass over an unknown cardinality. So that's why I didn't do it in this particular case. But yeah, that is, like Ecker said, it is a bit of a sharp edge.
Ecker, are you still in queue?
Okay, moving on. So I took 3 examples from the document. All of the examples are in the document and also in the GitHub in standalone files. And you're welcome to play around with the with validating and doing stuff like that for the CBOR ones if you're not familiar with it. So in TLS presentation language, on the left side, we have the original message example. And so, you're just sort of like taking the next element and just concatenating it, boom, 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 down the struct until you get to the bottom. The only places where you have lengths are for the length of the content type and the length of the content in this particular example. On the CBOR side, it's this is the extended diagnostic format, and so if it looks like JSON, that's because that was the idea, that it looked a little bit like JSON, except that you've got single quoted literals that are binary, that become binary strings. And so here we have a message which is pretty easy to read. Things separated with slashes are comments, and they're also end of line hash terminated or hash till the end of the line comments as well. I think that if a developer saw a debug of the thing on the right, I think it's going to be a little bit easier for them to see what's going on. Whether that's more important than reusing a library that we also potentially use with the Mimi protocol or not, that is, I think, a very interesting debate and question. Next slide, please. Okay, this is a more complicated example. So this is the edit message. So in this one, we have you're editing a message which was itself a reply. So so we're replacing a message. So we need to have an ID in the top line on the right-hand side here for the message being replaced. Topic ID and expires are 0. And then we're replying to the original message. So we have that message ID. And then I specifically wanted to have 2 last seen messages so that we would have a merge. And so here we've got 2, the last seen messages are the reaction message and the mention message. And then we have the straightforward body type here where we're just correcting the previous error. And then the EDN format on the right-hand side there, this shows the end of line comment type. Same encoding and content format and protocol. Yeah. Noted. Maybe we will, maybe we won't. Okay, next slide. Okay, I think this is the last slide I've got here. Yeah, so this is an example showing some external content. So this is somebody uploads a big file and then basically provides a pointer to this. And as intended in the previous draft 02, there is now a hash of the content that is available in the external content format here. Okay, any comments or reactions on this? Does anyone feel differently about which syntax we should use? Go ahead, Tim. Why don't you?
Thanks. So I guess both of these, I think will work just fine. In a vacuum, I think I might lean a bit towards CBOR in that like the tooling is better and it might be a little less surprising and less alienating to people trying to debug stuff in this environment. But to me, one of the main concerns here is consistency in which encoding is used at like different layers of the stack. So for instance, Richard in the chat was bringing up the possibility of using CBOR and MIMI protocol for the provider interactions, and that makes sense. But like the precedent that seems to matter here is that what we're already, I was going to say we're stuck with, but that's not true. We enjoy the opportunity to use MLS, which already is committed to using TLS presentation language. And that to me is like a pretty strong reason to use the same encoding in for content format and or MIMI protocol. Okay, so besides that statement, a question which maybe is during the pot. Does anyone recall why MLS doesn't use CBOR?
I think part of it was because we were leaning on the experience from TLS, and TLS uses TLS presentation language. The other thing is that the TLS presentation language is very focused on unique representation. So if you encode the same thing with TLS presentation language, there is no variability. You always get the same thing, which when you're dealing with inputs to cryptographic stuff matters a lot. And I think I seem to recall that CBOR has some flexibility in how you express things, which is undesirable when you're just making a crypto protocol. But it doesn't matter when you're talking about things like application stuff.
Yeah, I'm just going to point out that deterministic CBOR is a trivial way to get a single canonical representation of CBOR, and so that's what you would do, and that's what COSE does for cryptographic purposes.
Yeah. So I was actually in queue to say, like, this seems like it's making a pretty good case for just using CBOR throughout. I agree that using the same encodings up and down the stack makes sense, but I think that there's a pretty clean demarc between the MLS layer and the MIMI layer, which makes that a sensible place to change. Right. If you think about how in practice this is going to get built, like people are going to have an MLS library and they're going to have like a TLS encoder linked into that, but probably not visible externally. Like maybe it is as a shared library or something. But you know, like with the MLS libraries I've used, like the TLS encoding is not visible outside the library. So like there's not necessarily much savings to reusing that encoding elsewhere in the stack. And so given the kind of developer experience benefits that Rowan is pointing out here, like it seems sensible to use CBOR for the stuff that is less sensitive to some of the strict crypto requirements that MLS has.
So I think I'm still like leaning probably more towards Tim in terms of consistency. I guess I'm not like super persuaded by this tooling argument. My experience has been, I mean, the tooling does help, but my experience has been you actually write specific custom tooling to like handle the MLS cases, MIMI cases anyway, if you really wanted to do debugging. Like certainly if you like look at like, you know, what, like things like TCP dump and stuff like that, people just write something or you know, I guess Wireshark these days, people write things that like actually do a good job of this. And like this thing on the right, like frankly, is kind of like, I agree much better than the thing on the left, but it's still pretty impenetrable. And so I think, you know, I'm not going to like, you know, if we're humming, I'm going to vote for TLS. But if we're like, you know, I'm not going to say much more about it if we hum and it goes to CBOR. So,
Oh, I forgot to mention the analogy that came to mind, which is like HTTPS is like HTTP on top of TLS. HTTP's encoding is like totally different than TLS's encoding, even the binary ones in the more recent versions. I mean, in fact, if you're doing H3, like you have quick encoding, TLS encoding, and HTTP's binary encoding. So 3 different things in one stack. No, I think we can do better here, but there's some precedent for changing this stuff up.
Yeah, I'm just going to give my, you know, so I was like, you know, 55% for CBOR, 45% for TLS presentation language at Brisbane before I went and did this exercise. And now I'm probably more like 65% for CBOR, but, you know, I'm also not going to, you know, I think the most important thing is for us to make, a reasonable decision given what we've got in front of us. I'm going to implement it either way. Right? I do like the tooling, and I do see the arguments on both sides.
Yeah, okay, so putting on my chair hat, I guess. So the first and most important thing is that I don't think we can make a decision here. There's not enough people in this particular meeting. So we'll have to pursue this like on the list. And then I think we'll need to consider when and how we arrive at a decision here, like whether we can sort of do this in the consensus call of a list or if we would want to do it at a plenary. Otherwise, I don't know. I'm reading here like a slight lean in favor of CBOR, and it doesn't sound like it's a deal breaker even for the TLS presentation language likers. So my guess is that's how we would go. Okay, so what are we going to do next? I think the chairs are going to discuss how we want. Sorry, it's not like we need a decision here. I think the chairs are going to discuss like what forum we want to make this decision in. That'll either be a consensus call on the list soon, or worst case, it'll wait until Vancouver. I mean, is anything, Roden, would you say anything is blocked on this decision? You're muted.
Just if people wanted to start implementing, having a single concrete syntax would be useful, but there's nothing. We're not blocked.
Okay, so then I think the action is on me to talk to Alyssa about how we want to handle this, and then once we come to figure that out, Roden will probably come and talk to you about it.
Okay, and then if it's okay, I would like to spend 5 minutes looking at one issue on the GitHub for content.
Yep, sounds good. Bug scrub is what we were going to do next anyway. Do you want to share screen?
If you don't mind, yeah.
I do not. Hang on.
So
one sec, just finding the window.
This one is on content, Mimi content. It's issue number 15. Do we need a stronger hash for in reply to? External content hash and the message ID. So basically, I was kind of going over so CNSA 2.0 has the algorithms that the US government is recommending for, in going forward, and SHA-256 is no longer on that list. If they've come to this conclusion, there may be other people who have come to a similar conclusion. And so even if it's not being used in a sort of a strong cryptographic way, we can make the so we've got 3 places where we're using a hash, right? So both in reply to and for external content, the hash of the external content and the hash of the replied to message. There's a field that says which hash algorithm are you using, and then there's the hash that according to that particular length. So we could leave the default SHA-256, or we could make the default be SHA-384. So that's one question. And then, I can't imagine that we would want to do that differently for those two, for in reply to and external content. Then the second issue is the message ID. So currently, the message IDs we wanted to have be the, a hash of the ciphertext of the encrypted message. And we really wanted to have a fixed length field so that all the message lengths are the same. And so if somebody replies to a message later, even if the hash changes, that the length is the same. So we've got a couple of different choices. We could do, keep it SHA-256, We could use 384, but SHA-384, but we could make it still 32 octets long. We could make it the entire SHA-384 hash, or we could make it a variable length, which I really don't want to do that last one. So I was just curious if anybody had any feelings on this.
So, I mean, this is the first I'd heard that the NSA recommended not using SHA-256 for anything. Like the world runs on SHA-256, so like that's a little concerning, at least from a compatibility perspective. I don't think we should truncate. I don't know what the rationale is, but unless the rationale is they have an analytic weakness in SHA-256, then I don't think we should just truncate SHA-384 because it seems like that puts you back where you started. I guess I'd like to understand what the rationale was, why people think that 256-bit hash is not strong enough for these kinds of purposes. And if it's some kind of Grover's algorithm thing, then that's one thing. If it's like, anyway, Richard, it seems like you're online.
Yeah, I'm just note that CNSA 2.0 does not deprecate SHA-256, and in fact, it recommends it for some of the hash-based signature stuff. So it's not like that's going away. And I think that this would matter here if like we were relying on the full entropy of the hash. Like, I don't think if there's like, what's the consequence of a hash split? The risk with a quantum computer, right? The reason you double the symmetric key lengths is like it makes finding collisions harder, which is what Grover's algorithm is about. It doesn't seem like there's a security failure here. At best, at worst, there's a little bit of confusion, and like the Grover's algorithm speed up its quadratic, so we'd be reducing to like a 128-bit probability of collision. So like this is not seeming super fatal to me. So I would probably go with keep it SHA-256 here.
Ecker, are you still in queue? Okay, Richard just went. Okay, I'm inclined to agree with the two previous speakers, or rather to like defer to their superior expertise. But on top of that, I'm concerned about the performance cost of going to SHA-3. And so if we did do this, I think we'd want to consider one of the reduced round things. Like I think TurboShake is the one to consider. But that's only if we did decide to go SHA-3 by default.
I just want to be clear that SHA-384 is not SHA-3.
Oh, duh. I'm sorry.
384.
That's just SHA-2 384, right? I think, unless I'm like really tired.
Ecker, you're right. I got mixed up. Okay, ignore me. That was a non sequitur.
Is there somebody else is there another ATF working group or IRTF research group that we should ask this question to, or do we feel like we can just say, let's ignore this for now?
I would say let's ignore it until one of the there's a few PQ-wise messaging folks hanging around. So I would say let's ignore it until they come around.
Okay, I'm not hearing anybody saying we shouldn't ignore this. So yeah, I will leave this hibernating dormant for now. Thank you very much. I yield to the next presentation.
Well, sorry, one last thing, Ron. Do you want to make a note in this issue about what we just discussed? If only so that somebody who's watching this repository can get trolled into answering.
Yes, I am doing that as we speak.
Great, thank you. Okay, so next thing on the agenda with the remaining 20 minutes that we have is to do more scrubbing of open items on GitHub. And I've got some tabs queued up here to that end. So I think possibly we could get through one or two things. Before that, just want to check, did anybody want to return to anything, say, on the privacy preserving DS topic? Okay, guess not. So what we have here, Rowan, I think this one will be probably for you. This is the sole open pull request on Mimi content. Somebody wanted to add a README sometime last summer. You have thoughts on what to do with this?
If I convert from MMark to Cramdown, then I will use Martin Thompson's README that has the links to the GitHub pages. I may still get around to making GitHub pages work for MMark, in which case, if I do that, then I'll update the README. But I didn't really want to have sort of static README content around that would become stale.
I think I agree. I mean, this just seems to repeat the abstract from the document, and there's no point to keeping it up to date in 2 places. So in that case, the action here seems to me to be to explain, like, know what you just explained about your plans to clean up the README, and then presumably close this PR without merging it. That sound right?
Yeah, I can do that. Okay. And I don't think that the other issues on content are really worth discussing compared to probably what's on the protocol or architecture documents at this point.
All right, sounds good. Let me just tag this as reviewed, and then we'll move on to here. There we go. And we'll move on to protocol. Sorry, let me just double check. First off, for architecture, there's nothing that we haven't reviewed. There's just, it's about metadata leakage, which we talked about last time. I apologize for jumping between tabs so much. All right, so we've got this open pull request on Mimi protocol. Rowan, you're the author, though I notice it is a draft. Anything you want to say about this?
I think that we want to get the, sort of the core functionality. This was more so people could see that this was one of the functionalities that is included as something that would be required for DMA. That's something that's used by a lot of instant messaging systems. It's something that does need to go across provider boundaries. And so I just wanted there to be an existence proof that this was possible, but it's not like there's there's no burning reason to go and incorporate this into the document unless other people are asking for it.
So is there a requirement that needs to be discussed or explored here?
I think there is a requirement, but I think that coming up with in general the privacy requirements, the privacy threat model, and some of these other requirements that are more system-wide, I think that is going to be very valuable for us to have those first, because it may motivate slight changes in the approach that you would take for dealing with, for example, downloaded messages or attachments like this.
Okay. Well, in that case, it sounds like it's useful to keep this around as a draft, because, as you say, it illustrates something potentially useful and adds nuance to other ongoing discussions about requirements. Richard?
I mean, this does seem like functionality we will want in the protocol. So, I mean, let me ask the reverse question. Like, is there a reason to hold this and not merge it as an initial take at it to have it in the document?
I mean, I don't mind. I think it's pretty simple. I just don't want to spend a lot of time, if somebody wants to argue about some particular point of this, that it wouldn't be my highest priority in Mimi.
Well, to Richard's point, I have a slight concern about keeping PRs open or keeping pull requests open indefinitely, because they'll inevitably go stale or fail to merge. So if this is like our best understanding, if this is something that we know Mimi wants, and this is our best current understanding of how to do it, then perhaps we should take the change just for the sake of moving forward, acknowledging that we can always revisit it and change it later. So I guess the thing here perhaps is for the document reviewers to review the change and discuss it. Okay, I think that's all we got on that issue. So let's move on to This is, yeah, open issues on the protocol document that we have not previously reviewed. So let's see if we can clear out some deadwood in the last 15 minutes here. All right, so this one is about preparing a document for IETF 118, which, whether we like it or not, IETF 118 already happened. Is any of this still relevant? Rowan, I hate to put you on the spot. I guess you and Richard are here to speak as like authors or editors of the document, even though we don't have Conrad or Travis today.
Yeah, I think this is all stale.
All right, so in that case, whoops, why can't I type? All right, so I'm going to close this, and it can always be reopened should there turn out that there was something important here. Good, we're making progress. I'm helping. So this one was written up by Conrad. Maybe we should skip it since Conrad's not here to speak to it. Unless, Richard, Rowan, do you have thoughts on this? Seems to be fixed by a PR that's been merged.
Oh yeah, this one can be closed. This is done.
Good stuff. Okay, tracking arbitrary state. Which I suppose can mean room name and the like. Do we want to support this? Asks. Is that Matthew or is that Travis?
That's Travis.
Right. Okay, I think maybe we should skip this one and we can review it at some point when Travis is in the room. I'm scanning for stuff that's been, there we go. Okay. Han SN08 asks, do we need XMPP compatibility?
Yeah, we can definitely discuss this in detail in the next 12 minutes and close it down.
Fair enough.
I mean, my answer is no. So that's short.
Yeah, there's a lot here. I think Ecker's right. We don't have time to dissect this today. Okay. Is versioning too saucy for us to get into today?
That seems like something where, I mean, if people have ideas, I mean, it seems like we've got some recent, experience with this Acme versioning and things like that. I don't know, Tim, you and your colleagues at ISRG have done a lot of interaction with Acme and versioning there. Like any experiences that you've heard about there? Or from the DAP DPP evolution?
So initially in DAP in particular, we did do sort of explicit, I think we thought about doing explicit in-band versioning of the protocol. And we were talked out of it. Yeah, on the premise that the version negotiation is too complicated and risky. And then rather, if you're just changing the version, then you should just sort of expose the API from two different places. We did end up entangling protocol version into AADs for HPKE encryption, which ends up being useful because it ends up being an implicit check that like, yeah, you're running the same version, you know, your server's running the same version as the client. You'll fail to decrypt because you're using a different label in an AAD if you're not. So I like that, but I don't love the idea of requiring implementations of a server to support multiple different drafts at the same time. Eric?
Yeah, I mean, this seems like a much more complicated problem, frankly, than Acme or anything else I've heard. In that we have a potential situation where we have multiple entities and we have a real diversity of versions. And so, for instance, I think it might be useful to discuss like, do we, for instance, think that it should be the case that if we have the hub is A and then we have B and C, that B and C have to speak the same version of the hub. At least for a given conversation, and what happens, you know, what happens if the hub wants to migrate, you know, et cetera, right? For instance, do all the conversations have to go at the same time, or because you have like some conversations that are one on one to the other? I don't know answer any of these questions, but those seem like much more difficult questions, and these are much more long running. So it seems like trying to put together some kind of you know, theory about that is probably helpful. I'm definitely talking my way into believing that we're never going to have a version rev at this moment, but it's probably worth thinking about what we think ought to be possible. Well, I guess we close that topic.
Yeah, I guess no one else has anything to add to that. Go ahead.
I mean, I agree with Edgar about the problem of do all the providers that are participating in a room need to all support exactly the same version, right? So that's a good requirements, you know, that's a good requirements question.
The other thing that Eric's comments reminded me of was that if you look at, say, Matrix, I think they actually have 2 layers of versioning. One on the kind of exchange protocol and one on the room itself, which, you know, clearly there's kind of different notions of support there. You can envision, you know, having everyone has to support the room version, but maybe you support different transport versions underneath that. Might be a useful concept to import.
Okay, seems like that's all we got on that issue. I think, well, let's see if we can knock out one more.
This one is,
you want to add?
This is a placeholder to fix, like, you know, to fix way later. It's kind of like, this is like before working group last call, go do this. It's not, there's no.
Okay, as in sync up the artwork with like wherever these messages and interactions end up converging toward?
Yeah, it's just a bunch of make work, but there's no substantive change.
Cool. Thanks. Thank you. Okay. Richard, here's one of yours. So I think so this is a discussion seems to be still ongoing. My only observation here immediately is that I think we have exactly the same issue on the architecture document. Like, do we need both?
Yeah, I think we can probably close this one in favor of the architecture one.
Okay.
I think I just threw that as a quick stub to make sure that we track that. But if we fix the architecture one, then we'll flow it through to the protocol in more precise ways.
Thanks. Okay, we have just a few minutes left, and I think just at a glance, everything else in here seems like big questions or primarily stuff that'd be nice to have Travis in the room to speak to. So I'm inclined to give everybody 4 minutes back, or open the floor one last time if there's anything else anybody wants to quickly chat about. If not, go ahead, Richard.
No, I was going to say let's close.
All right, then the last thing I will note is, so thanks everybody for participating today. Let's see, there's a few actions that came out of today's discussion. The chairs will provide an update about like what we want to do about CBOR versus TLS presentation language. I think we're going to expect to hear more from Brendan and Rowan about the privacy preserving delivery service discussion. And otherwise, we'll see everybody in 2 weeks on May, whatever that works out to. For another interim, we're going to be back on Discovery. Go ahead, Ron.
23rd.
Thank you. On May 23rd, we'll be
22nd.
talking.
Sorry, 22nd.
Check the data tracker for accurate and up-to-date information on when the next interim is. And we'll see you all then. Thanks, everybody.
Thanks, everybody.